This is example 3, which is not the last example, but the next to last example for 10-6 using the quadratic formula. This is our real-world example, and for the ones you're going to do in your book, you're going to use the same formula I'm about to give you. But let's read through this first. A child throws a ball upward with an initial velocity of 15 feet per second from a height of 2 feet. If no one catches the ball, how long will it be in the air? Round to the nearest hundredth of a second. So this is just a parabola. We're saying how long will it be in the air. So from here where it started, how long is it in the air until here when it hits the ground? And here's the equation you're going to use. It's the vertical motion formula. Vertical motion formula. And you're going to use this on your real-world problem. And the vertical motion formula is h equals negative 16 t squared plus vt plus c. Now, v stands for the upward velocity. And c stands for the starting height. That's all you need to be able to find what we're trying to find here. So what we have is both those things that we need. We need the upward velocity and we need the starting height. So the upward velocity, let me try that again. The upward velocity is 15 feet per second. So that's our v, upward velocity 15. The starting height is 2 feet, so our starting height, c, is 2 feet. Okay, so we have all the numbers we need. Now we're just going to go ahead and plug in 0 because, again, we're trying to find our solutions. So we plug in 0 for height because we want to find how much time. We want to find t. If no one catches the ball, how long will it be in the air? We're trying to find time. How long? Time. So 0 for h so that we can find time. So we have negative 16 t squared plus, now v, upward velocity, 15 t plus c, our starting height, which is 2 feet. And then we just need to solve the way we've been solving this whole section, which is using our quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. So the only new part was this vertical motion formula that I introduced, and you're going to be doing the same thing every time. So you'll start by writing down your vertical motion formula, then you'll just plug in those two numbers they give you, your upward velocity and your starting height, which they'll give you in your problem. And plug in a 0 for h since you're trying to find the time, and then go ahead and use your quadratic formula. So remember, a is in front of your x squared term, b is your coefficient to your x term, and c is your constant. So we have the opposite of b, so b is 15, the opposite of 15, negative 15, plus or minus the square root of b squared, so 15 squared, minus 4 times a, which is negative 16, times c, which is 2, all divided by 2 times a, which is negative 16. We always work under the radical first. Negative 15 plus or minus the square root of 15 squared is 225. So 225, then do negative 4 times negative 16 times 2, and you get 128, so plus 128, divided by 2 times negative 16, which is negative 32. Okay, we're almost there. So equals negative 15 plus or minus the square root of, what is 225 plus 128? 353. The square root of 353 divided by negative 32. Now, I'm pretty sure this is not a perfect square, but go ahead and check in your calculator. What's the square root of 353? It's some decimal, 18.78829423. So let's go ahead and split it up now. X is negative 15 plus the square root of 353 divided by negative 32, or x equals negative 15 minus the square root of 353 divided by negative 32. Now, I know that it gets kind of confusing, so again, just remember that you can put all this in your calculator, and that way you'll get an exact answer, but I'll go ahead and round it this time to show you every step I'm doing. Negative 15 plus the square root of 353 is 18.7882, etc., divided by negative 32. So x is, now leave this in your calculator. If you took the square root of 353 and you had this in your calculator, leave this in your calculator and then just hit plus negative 15, or you can just do minus 15, which is the same thing. So when you subtract 15, you should get a positive 3.78829, etc. Leave that in your calculator and then divide that by negative 32. So just hit divided by negative 32. That's where you get that answer thing. So you have negative 0.11838, etc. But again, I believe they asked us to round to the nearest hundredth of a second. So we want to round to the hundredth place. The 1 is in the hundredth place. The 8 tells the 1 to go up. So we have x is approximately negative 0.12. That's one of our answers. And the other one, x is negative 15 minus the square root of 353. So you can actually put all this in your calculator at one time. You can do negative 15 minus second square root 353 and get your answer. That's negative 33.78829, etc. Leave that in your calculator and then just divide by negative 32. So you end up with x is approximately 1.05588, etc. So again, rounding to the nearest hundredth, the 5 is in the hundredth place, the other 5 tells the 5 to go up, so x is approximately 1.06. So your answers are, x is approximately negative 0.12 and 1.06, but since this is a real world problem and we were finding time, and really this wasn't an x at all these were t's, this was time, can we have a negative time? Would the ball be in the air for a negative amount of time? No, it would not. So in fact, we can throw this answer out altogether, and our only answer is 1.06 seconds. So again, you can put this whole top part in your calculator all at once. Negative 15 plus the square root of 353. Press enter and get your answer, 3.78829. Then divide by negative 32. Once you get a negative, you know it can't be your answer since it's a real world problem. Same thing over here. You can put this all in your calculator at one time. Negative 15 minus the square root of 353. Press enter, then take that number, divide it by negative 32, and you get your answer. Let's see. We could have done the same thing over here. If we had just done 2 plus the square root of 228 in our calculator all at once, and then pressed enter and got that answer and divided it by 14, we still would have gotten that though. Same thing here. This is really a harder way to do it. 2 minus the answer. Put this whole top line in all at once. 2 minus the square root of 228. And then take that answer and divide it by 14 instead of doing it this way. That way it's really harder actually. So just remember with the real world problems, obviously your answer has to be a positive answer. How long will the ball be in the air? It's not going to be a negative amount of time. That's what we were trying to find with time. So obviously you need to use that positive answer. All right, these are the methods for solving quadratic equations. So this is, we need to use this for our last example. Some of these we've done, some we haven't. Graphing, we definitely learned how to graph a quadratic function. We didn't use it to find the answers though, but you can. If you graph it, then you know your answers are just your x-intercepts. So find where your parabola crosses the x-axis, and those are your answers. Square roots. We really skipped this lesson, but you would use it if the equation has no x term. So for example, you might use square roots if you had an equation like 4x squared minus 16 equals 0. Then you could do that. And so, again, all we're trying to do is solve for x. So how would you solve for x? Well, let's put 16 on the other side. So you have 4x squared equals 16, since that canceled. And then square root both sides. Or you could divide by 4, either way. Square root both sides so that you end up with the square root of 4 is 2, and the square root of x squared is x, equals the square root of 16 is 4. And then how do you get x alone? Divide by 2 on both sides. And x equals, let's see, this should have been plus or minus 16, so plus or minus 4, so you get plus or minus 2 as your answer. So that's how you would, that's what they're talking about when using square roots. You use when it has no x term. Like this one, it didn't have an x term, you can use square roots, meaning solve for x. So take the square root of x squared, and that's, you'll end up with just x. Just make sure you have this plus or minus, because 4 times 4 is 16, but also negative 4 times negative 4 is 16. Then we have factoring. This one we definitely know how to do. Considering we spent a whole chapter on factoring, we know how to factor, and you can use it if you can easily factor the equation. We saw some of those in the first video. There were some equations we did using quadratic formula that we could have easily factored. So if you can easily factor it, go ahead and factor it. That's one of the least amounts of work. Completing the square. We did not do completing the square. Use if the x squared term is 1, but you cannot factor the equation easily. So actually, let's go back and let's find one of those that we couldn't have factored easily, but the x squared term was 1. Let's see. That's the beginning. So, I don't know if we're going to find an example here. We may have to just look at one of those later. And in fact, I think we will come upon one of those in a minute. And then I'll show you how to complete the square. And then quadratic formula, that's what we've been working on today. So your main ones, though, that you're really going to focus on, you can always graph and then just see where does your parabola cross the x-axis. You can factor, always try and factor, and then if it's easily factorable, then you don't have to do anything else. And then the quadratic formula, that works on any quadratic equation. So if you want a quick way to not have to sit there and go, oh, I don't know, what should I do? Should I factor? Should I graph? Should I try the square roots? I don't know. Quadratic formula works on every single quadratic function. It will always work as long as you use it correctly. So this one I would say is the most preferential. But in this next, and actually our last example, in our last video, we'll go through how you choose which one of these methods to use for each different problem that you have to do, which is going to be really beneficial on your final coming up.